Hello, hi everyone. Welcome to the Student the Brain. Till now, we discussed about light reflection and diffraction. So, in that image formation by concave mirror, we discussed. Next, we'll discuss about image formation by convex concave mirror. We discuss. This is about concave mirror. Now, we will discuss about convex mirror. Okay. So now we'll start convex mirror. Convex mirror we'll discuss now. Convex mirror. Convex mirror. Okay, so in this mirror there are two cases are there. Only two cases. Object is placed at infinity. So convex mirror I am taking here. So pole, focus, center of curvature, pole, focus and center of curvature. Object is placed at infinity. How many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. So one light ray I am taking like this, another light ray I am taking like this. After reflection, so if you are extending those light rays, the light rays are meeting here. Okay. So object is at infinity, image is forming at focus. Nature of the image is virtual and direct, and object is at infinity, image is forming at focus. Virtual, erect and highly diminished. Because point size image is forming at focus. Point size image is forming at focus. And coming to the next one, second one. Okay. So object is placed. So pole, focus, center of curvature, pole, focus and center of curvature. Object is placed. Object is placed in front of it. Object is placed. How many light rays are required? Minimum 2 light rays are required to form the image of the object. That's why I'm taking. One light ray I'm taking like this after reflection. So it will passes through focus. Okay. Passes through focus. Another light ray, so incidenting at the pole. Another light ray incident the pole like this. So it reflect back. Okay, if you are extending these light rays, so image will form here. Okay, so this is the pole. Object is placed between infinity and pole. Object is placed between infinity and pole. So image will form between P and F. Object is placed between P and infinity. Image will form between P and F. Nature of the image is virtual and erect. Virtual, erect and diminished. Virtual, erect and diminished. I hope it is very clear. Once again check here. Object is placed at infinity, image will form at focus. Nature of the image is virtual, erect, and highly diminished. So here, object is placed between P and infinity, image will form between P and F. Nature of the image virtual, erect, and diminished. Virtual, erect, and diminished. Okay. Next one. Next one we will discuss about so we'll discuss about sign conventions. Sign conventions. Okay. So concave mirror, convex mirror completed. Terms related also completed. Coming to the sign conventions. So here I am taking the pole. This is the pole. Focus, center of curvature. Pole focus and center of curvature. Pole focus and center of curvature. All measurements. So we have to take all measurements from the pole. In the direction of incident rays, all are positive. Object distance, image distance, focal length, and radius of curvature all are positive. So opposite to incident rays, object distance, image distance, focal length, and radius of curvature all are negative. Above the principal axis, all are positive. Above the principal axis, height of the object and height of the image. Above the principal axis, height of the image and height of the object positive. And below the image, height of the object and height of the image both are negative. Okay, as like a coordinate system if you are considering here. Okay, so this is the optic center, positive, sorry, origin, positive, negative, so positive, negative. Okay, so positive y-axis, positive x-axis, x-axis, negative x-axis, and positive y-axis, negative y-axis. Like that, here also all measurements will be taken from the pole in the direction of incident rays, all are positive. Opposite incident rays, all are negative. Above the principal axis positive, below the principal axis negative. Okay. So this is about sign conventions. New Cartesian sign conventions are simply we can say sign conventions. So just for remembering sake, I created one song related to this one. Just here. New Cartesian, New Cartesian, sign convention, New Cartesian, sign convention. All distance are measured from the pole. Distance are positive along the incident rays. Distance are negative opposite to incident rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian, New Cartesian, sign convention, New Cartesian, sign convention, all distance are measured from the pole. Distance are positive along the instant rays. Distance are negative opposite to instant rays. Distance are positive above the principal axis. Distance are negative below the principal axis. New Cartesian sign convention. New Cartesian sign convention. So like this we will discuss all the points. All measurements will be taken from the pole in the direction of incident is positive, opposite incident is negative, above the principal axis positive, below the principal axis negative. Okay. So as like coordinate axis, so coordinate system if you are taking, right? So origin positive x-axis, negative x-axis, axis negative y-axis. Okay, so next one. So this is about sign conventions. Next one we will discuss about mirror formula and magnification. Related that problems are there. So related to mirror magnification. So problems we need to discuss. We will discuss those points. Okay. Now now we will discuss about one more point. Mirror formula and magnification will discuss. Mirror formula is 1 by f equal to 1 by v plus 1 by u. Mirror formula. Magnification is minus v by u. So mirror formula is 1 by f equal to 1 by v plus 1 by u. So magnification equal to m equal to minus v by u. Minus v by u. I hope it is very clear. This is about mirror formula and magnification. Mirror formula and magnification. So magnification is defined as the ratio of height of the image by height of the object. Height of the image by height of the object is called magnification. Okay. Now, coming to the refraction phenomena, we'll discuss about refraction. Refraction. Refraction is nothing but, so I'm taking this thing. Okay, so this is a rarer medium and denser medium. Rarer medium and denser medium. Light ray is moving from rarer to denser. Light ray is moving from rarer to denser here. Okay, so I'm taking this a normal line. Normal line. And so if the light ray is moving from rarer to denser, the angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. Angle between incident ray and normal line is called angle of incident. Angle between refracted normal line is called angle of refraction. So here you can observe carefully, if the light ray is passing from rarer to denser, it bend towards the normal line because speed is decreasing. If the light ray is passing from rarer to denser, it bends towards the normal line. Speed is decreasing. Speed is decreasing. That's why it is bending. Okay, it's moving towards the normal line. So if the same thing, if light ray is moving from denser to rarer, so rarer and denser. So if the light ray is moving from denser to rarer, the light ray will move away from the normal line. So in this case, angle of incident is greater than the angle of refraction. Here, this is the angle of refraction and this is the angle of incidence. In this case, angle of refraction is greater than the angle of incidence. Why? Because here, in this case, light ray is bending towards the normal line. Light ray is moving towards the normal line. So, angle of refraction is decreases. So, angle of refraction is less compared to angle of incidence. Whereas here, so angle of refraction is greater than the angle of incidence because light ray is moving away from the normal line. Speed is increasing. That's why it's moving away from the normal line. I hope it is very clear about it. Refraction, the path of the light changes. The path of the light changes when it is moving from rarer to denser. The path of the light changes when it is moving from rarer to denser. That is called refraction. If it is passing from denser to rarer also, it moves away from the normal. The direction of the light ray changes when it is moving from one medium to another medium. If it is moving from one medium to another medium. I hope it is very clear to you all. Okay. So next. So very important points. Very important points. We will discuss those points. Those are critical angle and total internal reflection. And here loss of refraction is there. Loss of refraction or Snell's law also we can say Snell's law, and refract index we'll discuss. Refract index. So 2 points are there. We'll discuss those 2 points once again. I'm taking here. So incident ray. This is a normal line. This is a refracted ray. The angle between incident ray and normal line is called angle of incidence. Angle between refracted ray and normal line is called angle of refraction. So first point is loss of refraction. We will discuss now. Loss of refraction. Loss of refraction. So incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line lies in the same plane. Incident ray, refracted ray, normal line lies in the same plane. And coming to the second one, sine of angle of incidence to sine of angle of refraction equal to constant. Very, very important. So very, very important. Make sure that you are remembering this point. So these 2 points are very, very important. Refraction, loss of refraction. Loss of refraction. Incident ray, refracted ray, normal line lies in the same plane. Sine of angle of incident to sine of angle of refraction equal to constant, that is n. That is the refractive index n. Now we can take n equal to c by v. This is called absolute refractive index. N equal to c by v is absolute refractive index. Speed of light in vacuum by speed of light in medium. C equal to 3 into 10 power 8 meter per second. So speed of light in vacuum is air or vacuum. Speed of light in air or vacuum is 3 into 10 power 8 meter per second. So n equal to c by v. C equal to 3 into 10 power 8 meter per second. So this is absolute refractive index. Absolute refractive index is nothing but speed of light in vacuum by speed of light in medium. Speed of light in vacuum by speed of light in medium. Whereas relative refractive index, if you take 2 1, n2 by n1, that is equal to v1 by v2. Okay, so n21 if you are taking n2 by n1 equal to v1 by v2. So how you are writing? N is inversely proportional to velocity. Here from this one we can take n is inversely proportional to velocity. That's why n is inversely proportional. I am taking n21 if you are writing, and whatever the number comes first, even in the medium, if it is glass, so refractive index of glass by refractive index of water, like that. So whatever the medium comes first, that you have to write, and the next one you have to write in the denominator. N21. N21. Okay. So N21. So N2 by N1 or N12. If you are taking N12 also, if you are writing N12, so N12 if you are taking N12 is nothing but N1 by N2 equal to V2 by V1. V2 by V1. So very, very important. This is about loss of refraction. Loss of refraction. So make sure that you are attending. So make sure that you are listening carefully. So this concept is very, very important. Very, very important. Okay, highly important. Especially refract index. Based on refract index, one question will come. Definitely one question will come. Okay, so there are many ways to ask questions on this. Refraction. Refraction is nothing but the path of the light changes when it is moving from one medium to another medium. So incident ray, refracted ray, normal line lies in the same plane. The ratio sine of angle of incident to sine of angle of refraction equal to constant. Okay, speed of light in vacuum or air equal to c equal to 3 into 10 power 8 meter per second. N equal to c by v. N equal to c by v is absolute refractive index. N equal to c by v is absolute refractive index. Whereas relative refractive index n21 equal to n2 by n1, that is nothing v1 by v2. So n is inversely proportional to velocity. That's why n12 equal to n2 by n1 equal to v2 by v1. So this is about loss of refraction, absolute refractive index, and relative refractive index. Okay, so I hope it is very clear to you all. So questions will come on this. So make sure that you are practicing this one. Now we will discuss about critical angle and total internal reflection. Critical angle and total internal reflection. Very, very important. Listen carefully. Very, very important. So make sure that you are practicing and listening, understanding. So I'm considering here this is a normal line. So anyway, this is a rarer medium and denser medium. Okay, normally if the light ray passing from, so if the light ray is moving from denser to rarer, normally if the light ray is moving from denser to rarer, what happens? It moves away from the normal line, right? It moves away from the normal line. So this angle of refraction and angle of incidence. Angle of incidence. Right? Okay, done. Now you see here, same I'm taking. The light ray is passing, so this is the point I'm taking from here. If it is passing like this, okay. So at certain angle of incidence. So I will give an example. If you're taking like this, okay. So normally what happens if the light ray is moving from this rarer medium, denser medium, if the light ray is moving from, so denser to rarer, it moves away from the normal line. So if it is moving from denser to rarer, so we are keep on sending. So it's moving like this, again it is moving like this, it's again moving like this, and again at certain angle, the refracted ray passes or gauges along the surface. You are keep on sending the light ray from denser to rarer. Normally the process is, so if the light ray is moving from denser to rarer, it moves away from the normal line. It moves away from the normal line. So if you keep on sending at certain angle of incidence, the refracted ray, okay, so in the rarer medium, the refracted ray in the rarer medium passes or gauges along the surface. Passes or gauges along the surface. So it passes, the refracted ray passes or gauges along the surface, along the interference, like this. So this is called critical angle. Critical angle, or it makes 90 degrees with the normal line. 90 degrees with the normal line. So the angle at which the refracted ray passes along the surface or gauges along the surface or moves along the surface. Okay, so this angle is called critical angle. Critical angle, the angle at which the refracted ray passes or gauges along the surface. Passes or gauges along the surface, that angle is, this angle is called critical angle. Critical angle, very, very important. Critical angle. Next one, again, if the ray is passing from denser to rarer, if the light ray is passing from denser to rarer, again, so you can observe at a certain angle of incidence, okay, so the refracted ray reflect into the same medium, okay, so this angle, it makes more than 90 degrees or more than critical angle. So 90 is the critical angle, more than 90 degrees, then this light ray will reflect into the same medium. This light ray will reflect into the same medium. So this is called total internal reflection. So here we discussed, one is refraction, and second one is refraction, second one is critical angle, critical angle, and third one is total internal reflection, total internal reflection. Okay, total internal reflection. Once again, observe carefully here. Refraction means if the light ray is passing from denser to rarer, it moves away from the normal line. If the light ray is passing from denser to rarer, it moves away from the normal line. Critical angle is the angle at which the refracted ray passes or gauges along the surface. The refracted ray passes or gauges along the surface or makes 90 degrees with the normal line. So this is I'm taking normal, normal, normal. Okay, normal. So it makes 90 degrees with the normal line, normal line. So that angle is called critical angle. Total internal reflection. The conditions for total internal reflection, that is, light rays should move from denser to rarer. Light rays should move from denser to rarer. Okay, so it makes more than critical angle. So refracted ray makes more than critical angle. So in the rarer medium, then it reflects back into the same medium. Okay. So here you can observe 90 degrees plus theta. So 90 degrees is the critical angle. So this is the critical angle, and this is so the refracted ray making more than 90 degrees. That's why it is reflecting back into the same medium. Same medium is nothing but denser medium. It is reflecting back into the same medium. That's why that is the denser medium. So this phenomenon is called total internal reflection. Total internal reflection. So the total light internally reflection takes place. So you can see diamond. So diamond shines due to total internal reflection. Okay. And yes, optical fibers also, we are sending the information, right? We are sending the information based on this one only. I hope it is very clear, right? Next we will discuss about one more. Okay, so I hope it is very clear. Next one, we will discuss one more point. Glass slab, we will discuss glass slab. So I am taking the glass slab like this. Okay, glass slab. So refraction through glass slab, refraction through glass slab. So I'm taking this incident ray, and this one I'm taking the normal line, normal line. So this is the refracted ray, and I'm considering again normal line. So if the light ray is passing, so this is the rarer medium and denser medium. Rarer medium is the air, denser medium is the glass slab, denser medium is the glass slab. Rarer medium is there, denser medium is the glass slab. Light ray is passing from rarer to denser. Okay, the angle between incident ray and normal line is called angle of incidence. Angle between refracted and normal line is called angle of refraction. So angle between emergent ray and normal line is called emergent angle. So this angle is called emergent angle. Now I am considering here. So it moves like this. It moves away from the normal line. It moves away from the normal line like this. Okay, so this angle is called emergent angle. Okay, so once again listen carefully, observe carefully here. Incident ray, refracted ray, normal line, incident ray, refracted ray, normal line. So angle between incident ray and normal line is called angle of incident. Angle between refracted ray and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle of emergence. And now you can consider here. So this angle is called, okay, the angle between emergent ray and normal line is called angle of emergence. So the distance between emergent ray and initial direction of the incident ray, angle between emergent ray and initial direction of the incident ray is called is called lateral shift. Lateral shift. Lateral shift. Okay, so lateral shift. I hope it is very clear. Lateral shift. Is it clear? Lateral shift. Once again, incident ray, refracted ray, normal line. Incident ray, refracted ray, normal line. Angle between incident ray and normal line is called angle of incident, and angle between refracted and normal line is called angle of refraction. Angle between emergent ray and normal line is called angle of emergence. Angle of emergence. Okay, so a rarer medium, denser medium, lateral shift. The distance between emergent ray and extended incident ray is called lateral shift. Lateral shift and vertical shift also there. Vertical shift, that is nothing but, okay. So very important points we will discuss. So if you are taking the glass beaker, so inside of that one what? So normally, so you place the coin. So if you place the coin, so coin is at the bottom of the beaker. Coin is at the bottom of the beaker. You are standing here. You are standing here. You can't able to see the coin. You can't able to see the coin. Okay, before that. So after pouring water, so the coin position rises up. The coin position rises up. So the coin position rises up here. Okay, like this here. So the distance between actual position to apparent position is called vertical shift. Vertical shift. Distance between actual position to apparent position. So this is the actual position of the coin and this is the apparent position of the coin. So the distance between these two is called vertical shift. The distance between this is the actual position of the coin, apparent position of the coin. The distance between actual position and apparent position is called vertical shift. Okay. And one more example. So you can take the lemon placed inside of the beaker. It appears bigger. So if you are placing the lemon, so if you place the lemon, okay, lemon if you place lemon inside of it. So it appears bigger. It appears bigger. So if you place a lemon inside of the water beaker, so it appears bigger due to refraction of light. And one more example, we can take pencil placed. So pencil is placed here. So I am taking here. So one more example, pencil I am taking. Okay, so if you place the pencil inside of the water beaker, so I am taking this pencil like this. Okay, here. So actually it appears here. So at the interference between water and air, the pencil appears to be bent. So this is the pencil I am taking. Pencil I am considering here. So the interference between water and air, okay. So the pencil appears to be bent. So this is about refraction. So these three examples we can take. Okay, vertical. So this vertical shift is nothing but the distance between actual position to apparent position of the coin is called vertical shift. So lemon appears bigger due to refraction of light, and here pencil if you place inside of the water beaker, it appears to be bent. So here, and the lateral shift is nothing but the distance between emergent ray to and extended incident ray. So initial direction, the vertical shift. Okay, vertical displacement between emergent ray and initial direction of the incident ray is called lateral shift. Lateral shift. I hope it is very clear. So it is very clear about it. So this is about refraction through glass slab. Refraction through glass slab, right? So now we will discuss about one more concept, that is lens. So lens will discuss. Now, so we are going to discuss about one more point, that is lens, convex lens and concave lens. Convex lens and concave lens. Concave lens and convex lens. So there are two lenses, convex and concave. Okay, so When the light rays are falling, when light rays are incidenting on it, light rays are incidenting on it. Now we will discuss about lens. Okay, convex. There are two types of lenses are there: convex lens and concave lens. The convex lens. So this is a part of this sphere, and here also part of this sphere. So optic center F1, 2F1, F2, 2F2. That is also C2 we can take. This is C1. Even for concave lens also, concave lens I am taking here. So optic center F1, 2F1, F2, 2F2. Okay, so it's a part of this sphere, and here also part of this sphere. Right? Now we will discuss about ray rules of convex lens and concave lens. Ray rules of convex lens and concave lens. Ray rules of convex lens and concave lens. Okay. Now you can see here ray rules. Ray rules. First one is convex lens. Convex lens. The next one is concave lens. Concave lens. Convex lens and concave lens. Coming to convex lens. So optic center F1, 2F1, F2, 2F2. So light ray is passing after refraction, it passes through focus. First one. Coming to the second one. The second one I am taking here. Optic center F1, 2F1, F2, 2F2. Light ray is passing through F1. After refraction passes, and coming to the third one. Light ray is passing optic center F1, 2F1, F2, 2F2. Light ray is passing through optic center, so no deviation takes place. Okay, coming to the concave lens. So concave lens. Concave lens. Optic center F1, 2F1, F2, 2F2. Okay. Here light ray is coming parallel to the principal axis. After refraction it passes through the focus. Coming to the second one, optic center F1, 2F1, F2, 2F2. Light ray is passing through focus. Light ray is passing through focus. After refraction passes parallel to the principal axis. Coming to the third one. So this is about, so optic center, this is the optic center F1, 2F1, F2, 2F2. Light ray is passing through optic center. Light ray is passing through optic center. Okay. No deviation takes place. It moves like that only. Okay. So once again, so convex lens and concave lens. Convex lens, light ray is parallel to the principal axis. After refraction passes through focus. Light ray passing through focus after refraction moves parallel to the principal axis. Light ray passing through optic center. So no deviation takes place. Here also, light ray is parallel to the principal axis after refraction moves, passes through focus. Here also, light ray passing through focus after refraction moves towards infinity. Light ray passing through optic center. So no deviation takes place. I hope it is very clear about it. Okay, so convex lens and concave lens. Convex lens and concave lens. Right? Next, so we will discuss about image formations. Image formations of convex lens and concave lens. Image formations of concave lens and convex lens. Now we will discuss about convex lens and concave lens image formations. So image formations we'll discuss, right? Okay, so mhm, 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 mhm. So light ray object is at infinity. Object is at infinity. Object is at infinity. Image will form focus. Object is at infinity. Image will form at focus F2. Nature of the image is real and inverted. Size of the image is highly diminished. Coming to the first one. So second one is object is placed beyond to F2. Object is placed. So here I am taking optic center F1, 2F1, F2, 2F2. So object is placed behind 2F1. One light I am taking like this. It passes through focus. Another light ray is passing through optic center. Another light ray passing through optic center. Mhm. 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 Okay. So now you can observe here. Observe carefully. Object is beyond 2F1. Beyond 2F1. Beyond 2F1. Image will form between F2 and 2F2. F2 and 2F2. Nature of the image is real and inverted. Real and inverted. Size of the image is. Nature of the image is real and inverted. Size of the image is diminished. Diminished. Okay. So diminished. Diminished. Coming to the third one. Third one. Optic center F1, 2F1, F2, 2F2. Object is placed at 2F1. Image will form at 2F2. Image will form at 2F2. Okay. One light I am taking like this. It passes through focus. Another light ray passing through optic center F2 and 2F2. Object is 2F1. Image will form at 2F2. Object is placed at 2F1. Image will form at 2F2. Nature of the image is real and inverted. And size of the image is same size. Okay, same size. So 1, 2, 3. So 3 image formations. Next one now. We'll discuss 3 more. Okay. So take short break. Little break. So, welcome to the class. Till now, we discussed about convex lens image formations. Convex lens image formation. So, again, fourth one, convex lens. So, optic center F1, 2F1, F2, 2F2. So, now object is placed between F1 and 2F1. So image will form beyond 2F2. Object is placed. Okay. Now we see one light ray I am taking like this. It passes through focus. So it passes through focus. Another light ray passing through optic center. So those light rays will meet here. So here I am taking. Okay. Object is placed between 2F1 and F1. Image will form beyond 2F2. Beyond 2F2. Nature of the image is real and inverted. And enlarged. Okay. Coming to the fifth one. Object is placed at F. So I am taking optic center here. So F1, 2F1, F2, 2F2. Object is placed at F1. Image will form at infinity because so parallel light rays will meet at infinity. So I'm taking one light ray here. It passes through focus. So light ray is passing through optic center. So those light rays will meet at infinity. Object is placed at F1. Image will form at infinity. Nature of the image is real and inverted and highly enlarged. Real and inverted, highly enlarged because image is formed at infinity. Okay. So now sixth one. So object. So this is the optic center. F1, 2F1, F2, 2F2. Object is placed between F1 and O. Image will form same side of the object. Okay. So one light ray I am taking like this. So after refraction passes through F2, another light ray is passing through optic center. If we are extending those light rays, okay, so those will meet behind same side of the object. Okay. Object is placed between F1 and O. Very, very important 3 marks question. So, okay, nature also they will ask, 1 mark also they will ask. So, make sure that you are preparing this one, practicing this one. So, image is forming same side of the object. Nature of the image is virtual and erect and enlarged. So, enlarged image is formed, right? Virtual, erect and enlarged. So, very, very important. Make sure that you are practicing this question. Especially this diagram, right? So, done. Now, we will go with the concave lens. Concave lens image formation. Concave lens image formation. Okay. Concave lens. Concave lens image formation. Now we'll discuss. So problems also there. So problems we need to discuss related to refractive index, absolute refractive index, relative refractive index, and mirror formula, magnification. Okay, so concave lens, concave lens, concave lens. We'll discuss. First one is object is at infinity. One light I'm taking like this. Okay, so optic center F1, 2F1, F2, 2F2. Object is at infinity. Object is at infinity. So I'm taking two light rays. So those are reflecting like this. And here also those are reflecting. Okay, so if you are extending these light rays, will meet at focus. Object is at infinity. Object is at infinity. Image will form at F1. Nature of the image is virtual erect. Virtual erect and diminish. Virtual erect and highly diminished because point size image is forming. And the second one, object is placed. So here you can take object is placed. Optic center here F1, 2F1, F2, 2F2. Object is placed here. So one light ray I am taking like this. It reflects back. Another light ray is passing through optic center. So if you are extending these light rays, we are extending these light rays. Okay, so object is, so image will form here. Object is placed between optic center and infinity. Image will form between F1 and O. Nature of the image is virtual erect. Virtual erect and diminished. Nature of the image is virtual erect and diminished. Right? Nature of the image is virtual erect and diminished. Diminished. Right? Next one. Lens formula is 1 by f equal to 1 by v minus 1 by u. Magnification equal to height of the image by height of the object. That is nothing but v by u. Power of lens is positive for convex lens. Power of lens is negative for concave lens. Power of lens is positive for convex lens. Power of lens is negative for concave lens. What is the power of lens? The degree of converging or diverging of lens. The degree of converging or diverging of lens achieved is known as power of lens. P equal to 1 by f. So P equal to 1 by f, reciprocal of focal length. Reciprocal of focal length. Power of lens is positive for convex. Power of lens is negative for concave lens. I hope it is very clear. So this is about light reflection and diffraction chapter. Light reflection and diffraction chapter. So related to light reflection and diffraction, we need to discuss problems. Problems are there. And next, human and colorful word, electricity, magnetic effects of electric current, like this topics are there. So stay connected with the student brand. Continuously will practice all the chapters. Those who are studying in 10th class, so check once all the concepts. Okay, so practice carefully, prepare well. Okay, so if you like this content, do like, share, and subscribe to Student the Brand. This is Evasavasa from Student the Brand. Thank you so much for joining and attending and listening the class. This is Evasavasa. Thank you.